I cordially invite Engineer Shubha TG for the introduction of the faculty and the welcome speech. Shubha, please. Shubha, please unmute. Shubha, please unmute.
Shubha, can you please unmute once again?
Okay. Good evening. KCB Engineers Association has been working relentlessly for the improved functioning of our organization and also constantly striving for the improvements of service conditions and quality professional work by its members. KCB Engineers Association is always in the forefront for dissemination of technical knowledge. Various technical seminars, handbooks, quality technical journals, webinar series, seminar series are some of the examples in which Engineers Association made its stamp in the technical empowerment. Today, Engineers Association creates another milestone by presenting its 56th webinar on the importance of geothermal energy and its applications with pride. Geothermal energy is an energy source that is stored in the form of heat beneath its Earth's surface, which is clean, renewable, sustainable, carbon-free, continuous, uninterrupted, and environmental friendly. In its quest to increase its renewable energy portfolio, the government needs to tap into the potential of geothermal energy sources, which is still at a nascent stage. A series of wells is used to generate steam from the Earth's internal heat energy and fed to the power plant to generate electricity. It is the only renewable energy available 24/7 to the mankind, not requiring storage and unaffected by day-night or seasonality variance. India has 7 geothermal provinces and number of geothermal springs. Geothermal resources in India have been mapped by Geological Survey of India, and broad estimates suggest that there could be 10 gigawatt geothermal power potential as per Ministry of New and Renewable Energy. Energy major ONGC will implement India's maiden geothermal field development project in Ladakh. A memorandum of understanding to formalize this has been inked by ONGC Energy Center with the Union Territory of Ladakh and Ladakh Autonomous Hill Development Council Leh on 6th February 2021. This MOU, which was signed in the presence of Ladakh Lieutenant Governor, is a first step towards creating a carbon-neutral Ladakh, a clarion call given by the Prime Minister of India on Independence Day 2020. So today, we got the most authenticated faculty of Izmir Institute of Technology, Turkey, Professor Dr. Alper Baba. Dr. Alper Baba holds a degree in geology and a doctorate in the field of hydrogeology from the Docus Elul University, Izmir. He has 25 years of experience in hydrogeological and environmental geology problems in different parts of the world. Since 2010, he has been a professor at Izmir Institute of Technology as a director of International Water Resource Development. He is teaching and conducting research in the field of environmental geology, groundwater contamination, geothermal energy, and hydrogeology. He has coordinated a variety of national and international R&D projects in cooperation with research institutes and companies, among them NATO, World Bank, EBRD, and EU-funded projects. Dr. Baba was awarded the Successful Young Scientist Award of the Turkish Academy of Science and the Turkish Geological Engineering Association Gold Medal Award. Dr. Baba is the author of several peer-reviewed scientific publications and contributions to international conferences and is the editor of book Groundwater and Ecosystems and so many. So, hearty welcome to you, sir, together with Dr. Chegam Ozelli and Dr. Chandrasekharam. Thank you.
Thank you very much.
Thank you, sir.
Dear my colleagues, ladies and gentlemen, really I'm very happy to be with you. Thank you very much this nice invitation for this important webinars. Today I'm very happy. Also I work with my colleagues, Chandra, he's also in my university. We are work together about geothermal energy. Yes, today I'm going to give a little bit information about the energy of the Earth. Then I will give you some information about what is the situation of the geothermal, how the geothermal is going to be affected the life system and then economy of the country. As you know that this is the world energy consumption distribution figures. In here, we have a green color. This is most of them is oil. We have some black color. This is the coal. The red one is the natural gas. As you see that in here, most of the country depend on the fossil fuels. But this line, boundary between fossil fuels and fresh renewable energy. As you see in here, especially the many European countries have been focused about renewable energy. In renewable energy, you can see that such as the nuclears, biofuel and waste, hydropower, but also it is nice, we can see the geothermal. The red one is the geothermal in here. As you see that in the Japanese, in Turkey, in the, you know that in Italy, New Zealand, Iceland, you know that some European countries now make a strategy to improve their renewable energy, especially the geothermal. As you know that if you look at the global energy statistic, about at the time, about 80% of our energy comes from fossil fuels in the world. But renewable energy just about 11.2. But if you look at the renewable energy, you see that most of them is consist of the biomass, solar, geothermal, but also we have a hydropower. We have also the other wind, solar, biomass, and also the ocean powers. But if you look at the global energy statistic, you know that this is the show that the growth in the global renewable energy compared to the total final energy consumption. As you see that in here, the modern renewable energy going to be increased related with the date. But the other one, the traditional biomass and then the other fossils is going to be decreased in the world. Generally, all the energy is going to be increased in the world. You know, this is the total energy consumption, as you see, that going to be increased. Last, you know, the average, for example, 2006 and 2016. But fossil and nuclear energy is going to be increased in the world. But it is nice to see that modern renewable energy going to be increased more. This is like a 4.5% in the world. Generally, if you look at the 2008, 2018, as you see that non-renewable energy is, you see that non-renewable energy going to be decreased, but you see that generally this color, yellow color, is the renewable energy. As you see that renewable energy going to be increased in the world. As you know that if you look at the just generally statistic, but to 2080, but it's not so much change. You see that the global electricity production countries, especially you know that China, United States, India, Russia, Japanese is the biggest production. If you look at the consumption, again, these countries, China, United States, India, and Japanese, they consume so much energy, but most of them is this country used to fossil fuels. If you look at the renewable energy in the electricity production, as you see that in here, the now is especially the Norway, because the energy come from hydropower. New Zealand is the energy come from the geothermal, and then Brazil is they especially used to hydropower. Colombia, Venezuela, and then other South American countries, they used to they produce the energy from the hydropower. But also in the other countries, you see that such that the Germany, they produced more at the time wind and solar energy. If you look at the shares, the total percent share of the wind and solar energy is growing rapidly and steadily. As you see that in Germany is about like a 25%, but this data is changed by day by day, because after the Ukraine Russian problems, the war, now that these countries is this more focused about the renewable energy. For example, now the Netherlands, they focus about the geothermal more, and then Germany, we have seen that some directives about geothermal now in some many parts of the countries. As you see in here, for this Germany, Portugal, Spain, New Zealand, they have a wind and solar energy in the world. But I'm happy. I also in the Turkey now. Turkey is the government is really supported the solar energy and the wind energy, and then also the exponential is going to be increased in Turkey. In here, we are going to focus about the geothermal energy. Geothermal is a really very important energy. It is not easy, that to compare with other energy, because, for example, when you discuss about the solar, when you are discuss about the, that the wind power, the efficiency is very low, but for example, the power energy the efficiency is about near the 90% someplace. Geothermal energy is among existing renewable energy sources, is the only source that can provide base load electricity and efficiently replace fossil-based energy sources, as it is secure, inaccessible, dispatchable, and flexible. Geothermal energy is contained in rocks, mostly as a hot fluid and steam within the earth crust. And it is available at all time through the years, unlike other intermittent renewable energies. Dear my colleagues, as you know that the sun's temperature is around 5,000, exactly 5,000, but don't forget, the earth crust, the core temperature is reach 6,700 degrees. The meaning that in near futures, most of the countries will going to focus about the earth temperatures more than sun temperatures. But if you have a geothermal underground, if you have a different temperature, we can use for the different application. For example, if you have a 10 degrees and 20 degrees, it is possible you can use for the heat pumps. If you have a little more temperature, like a 38 degrees, it is possible you can use produce the fish farming. And then if you have like that 60 degrees, 66 degrees, it is possible you can use for the greenhouses. And then if you're near the 100 degrees, it is possible you can do some food processing. It is possible you can use for the cement industry. If you have like 80 degrees, you can heat it your cities, houses. And then if you have more than 80 degrees, you can use for the power generation. You see that this is the cross section, show that the shallow system we can use for the heat pumps. If we have a hydrothermal system, if you have a fluid, we can use for the power generation. If you have like a more than 80 degrees, you can use for flushing binary power system, you can produce the electricity. But sometimes some region they have not fluid, but still they are source, still they are hot, but it is possible you can use this heat, because for example you have heat source but you have not fluid. It is possible you can inject the fluid underground and then heat it with the energy, and then again you use this energy for the power generation, maybe direct use in the system. We call that this system an geothermal system. Okay, if you look at the geothermal energy in the top countries, as you see that Turkey is now in the fourth. Today I'm going to focus a little bit, give good example about Turkey, because Turkey is exponential increase. This is very good sample in the world. Generally, if you look at the top 10 geothermal countries, the first one in the United States. This is the about the 3,714 megawatt electricity. After then, Indonesia, Philippines, and Turkey. At the time, it is 1,663 megawatt electricity, and then also New Zealand is the more than 1,000 megawatt electricity. But we can see that other countries they use and they improve their geothermal energy. But if you look at the global geothermal power generation capacity was 15,608 megawatt at the end of 2020. You see that each year is going to be increased, you know, in the world, capacity is going to be increased. But when this is the power generation, but also we can use the geothermal energy for the direct use. Direct use meaning that you can use for the heating, cooling, drying, fish industries, you know, that the different application. But this figure show that the exponential going to be increased total direct use energy capacity in the world from 1995 to 2020. If you look at the 2018, the installed geothermal power capacity grew about 5% in the world, 5%. But if you look at this 5%, 32% come from Turkey. As you see that 25% from Indonesia, 22% come from Kenya, also Costa Rica, Japanese, and then the other countries like Mexico, United States, Germany, is they added some power capacity in the energy system. This figure show that about how the power generation, geothermal development increased in Turkey. In Turkey, we start in 1985 for the power generation. At the time, we have just 50 megawatt electricity. In the one of the Graben, we call that Büyük Menderes Graben. But after 2007, because of some energy crisis in the European, and then Turkish government started to support the renewable energy. They added some tariffs, and then after then, power generation is exponential going to be increased. You see that in here, at that time, 1,660 megawatt electricity. And this is the situation of the power generation in Turkey. In Turkey, at that time, most of the power generation located in the western part of Turkey. This is the western part. In here, we have two important grabens, very important for also the agricultures, very important for water resources, this area. We call that the Büyük Menderes Graben, like a plain. And then the other one is a Gediz Graben. This region is very famous for the fig, and this one is for the grapes. In here, as you see that we have total 63 power generation. But if you look at see that the type of power generation, most of them is binary system, ORC system. And then also in Turkey, we have a double flush, binary, we have a flush, single flush, and then also we have a triple power generation, geothermal power generation. And then, as you know that if you look at the geothermal power generation, we have generally three systems. One of them dry steam plant. In here, they have a production wells and injection wells, reinjection wells. In geothermal system, we used to the fluid in the turbine because they have a gases and then they have fluid. After turbine, you can produce the energy, but then you see that in here, in the systems, you can reinject the fluid underground again, the same reservoir. In the flush system plant, we product the fluid from production wells, and after the separator, we send to again the fluid in the turbine, and then produce the energy with the gas. After then, the other fluid reinjected the underground system. But also we have a binary cycle system. In binary cycle system, you production fluid, and then fluid go to the heat exchanger, and after then go to turbine, produce the energy. After then, turbine go to the heat exchangers again, recharge, the inject underground system with injection wells. And then this is one of the sample about the binary cycle power gen plants. You see in here, production wells, pumps, go to the heat exchanger, working fluid, go to the turbine, and then in turbine after that, the fluid, sometimes the temperature fluid going to the heat exchanger, it's a closed system. And then and then also we use to the cooling system. In Turkey, in the cooling system, most of them air cool, but in some fields, some power we used for the cooling with water. And then this is some sample about flash geothermal power plants. Again, this production going to separators, and then they produce the energy. After then, separator, the fluid again going to the reinjection system. And then this is the double flush geothermal power plant production wells going to the separator. As you see that 2 turbines, 2 separators, and then they go to steam, going turbine, produce and then after turbine going to generator. And then again, you see that we again the fluid, the low pressure systems, they're going to down. We can again just send to the reinjection system. And then this is a simplified diagram for single flush combined with the binary plants. And then we have also, you see that we have a production well, we have reinjection wells in here, again going to the separators, and then they purified and going to turbine and generate electricity. But after then, separator, the fluid, they're going to the evaporators. That again, the evaporator again you can use for to use turbine and generator. But after then, if you have fluid, the other fluid going to the pipe go to the injection wells. Okay, we have a different system in the Turkey. We have all the system in Turkey in this power generation. And then in the geothermal system, we have a with geothermal power plant and without power plant. For example, this is the with power plant. For example, you have a production wells, and then you have again this is the you see that we are separated the fluid, the gas is going to the production turbine to the power generators power. Then after then we can use this fluid with the that heating and cooling house, thermal facility, mineral recovery, greenhouse facility, that different application. We call that this one cascade system. But also we have used to geothermal without power plant. For example, we have not used the power plant, but also we use this fluid, that for the cooling and heating, we can use for the thermal facility, greenhouses, fruit dry, and then different application. After that, this fluid going to the reinjection well. And then after the power generation, also we used for the geothermal for the direct use application. For example, this is show that how the direct use application is used in the different countries. You see that now Iceland, they use more, but second one, the biggest one in the Turkey. And then this is the figure show that the plant in the operation and then plant under the extension. But I believe that in near futures, like a French, Germany, Hungarian, Iceland, the other country, they start use so much for the direct use application in the Europe. Okay, all the system is related with geology. Especially, I know that the Indian geology also very complex because they locate in Himalaya systems. In here is a geological of the region is very complex. I'm not going to so much detail about geology, but this is affected the quality and then the characteristic of the fluid in the system. But in here, this is the map of the European side, and this part is Turkey. As you see that this is data from 1,000 meter and 2,000 meters. If you look at the 1,000 meter, the temperature is in this region around, you see that in here, around 40 and 50 degrees. But if you look at the Turkey, the 1,000 meters, the temperature is reach about 60, 70 and 100 degrees. But if you look at going to 2,000 meter, you see that in here, especially in our country, Turkey, you see that temperature is the exit 200 degrees. This is very important for the application. Why the Anatolia? This is our country for Turkey? Because the Anatolia is, the Turkey side. This is located in the, that the Alp Himalaya orogenic system. We have a, this line is the major fault system in here. This is you see that in here. For example, this is the truss fault system in here, and then this part we have a strike slip fault system in here, the important fault, and then this part of the Turkey, the eastern near the Iran regions. This is the compression, like a mountain region. But in here, we have an extension system. This is, for example, this part we call it Neogen extension basin. For example, the brown one is the Alpine fault thrust belt, this region. But also in the center of the Europe, we can see that Neogen oceanic crust. This is the extension zone in this part. And then this is the map of Turkey. You see that this is the fault fracture. And then this is this is the South Anatolian fault system. But we have a many fault line. The black one is the line, the fault. But in here, as you see that we have a different color, like a pink colors, and then yellow colors. This is some volcanic activity, volcanic region. For example, this is the yellow one is the Neogen volcanics, and then red one is the granitic metagranitic system. This is the the heat source of the system. This produces the energy. If you look at this map, as you see that this is very active because more tectonics. They have a volcanics. They have a magmatic systems. This is affected the geothermal system. Exploration geothermal system. And then therefore, each red one, you see that it's red dot, is show that geothermal wells or springs. If you look at these maps, you see that all part of the country, they have a geothermal. You see that in here, again, this red one is the geothermal wells, but most of the wells was done in western part of Turkey, and then southeast of the Turkey. This one, we have in here, we have a more than 1,000 wells, they production wells, reinjection wells, the research wells, but the temperature range from 20 to 209 degrees in this system. In this part of the Turkey, we have oil wells. But you know that if in the oil system, oil wells, they have a fluid. For example, they produce the oil, but it is possible you can use the oil wells also with the geothermal, because in this region we have a hot water. For example, in this site we have a 97 wells, and then the temperature range from 40 to 170 degrees. Okay, this is the temperature distribution of the Turkey according to the well data. As you see that in Western Anatolian, this part, the temperature is very high. This is like, more than 200 degrees. But at the time, one of the drill was done in the Turkey, in here, the temperature reached 341 degrees. But the depth of the wells is 3,945 meters. As you see that still many parts of the countries, they need for the power generation. They wait, that exploration, they wait some new wells. But we have very good sample about cascade system, the meaning that we can use power generation and then the other direct use application. For example, in here, this is the power generation of the Turkey. I live in the Izmir city, western part of Turkey. In here, we have one of the power generation. But the other one, in here, some power generation, they use power generation, electricity, but also they have heated by the city. For example, this power generation in the Deniz region, they heated 5,000 houses in here. And then also in this part, they use for the greenhouse. For example, they used after the power generation, they use fluid for the greenhouses. This is, you see that 41,400 square meters. Again, we can see that the other part in this region, for example, again, this region also the solid region, we use for the power generation, but also we heated 4,000 houses in here. Dear my colleagues, as you see that in here, most of the city in Turkey, we have 81 cities, like 63 cities, they have a geothermal source. We have many wells still, more than 1,000 geothermal resources, and then we have a production wells. But the other important thing in the world, geothermal direct use application in the world. If you look at the world, about 58.80% they use for the ground source heat pump. For example, if you are going to the Sweden at the time, Stockholm, Lund, the city heated by the heat pump of the geothermal. And then after then, they use for the, you see that bathing and swimming, 80%, 60% is space heating, 3.5% is greenhouse, and then 1.6 is the industrial process. And then the other 1.3 is the aquaculture pond and reverse water heating. Dear my colleagues, if you are, checked the world with heat pumps at that time, China, United States, Sweden, Germany, and Turkey. Turkey is a 5. But without heat pumps, after the China is a Turkey. Okay, as you know that in the hydropower, geothermal power, we are the 4 in the world, but with the direct use, we are second in the world. A good application. As you remember that I say that if you have high temperatures, that more than 80 degrees, that it is possible you can use for the power generation, binary, flash, or dry steam geothermal power plant. But if you have a lower temperature, you see that you can industry drying, food process, greenhouse application, that fish farming, and then heat pumps. Also hydrogen production. If this is the map of Turkey, as you see that each part of the Turkey, we can, that some ruins. Why? Because the Romans, Romans came in here and then used the geothermal fluid and then for the treat of the people. Still, we can see many, many ruins in different parts of Turkey. They used the geothermal at the time. This is one of the geothermal fields in Turkey. You see that this is the Pamukkale region. Normally, this is the scaling, that the scale, but scaling is for engineering is a problem, but sometimes they make a very nice nature, value. For example, this one, you see the colors is very nice picture, but because of the geothermal fluid, the scaling. You can imagine if you have a kettle in your house, you are boiled water, but in kettle you see some carbonate, scale, this scaling. Okay, generally we have a very good example in the Turkey about this. Okay, if you look at the direct use application in Turkey, the total current installed direct use application have thermal capacity is more than now 3,501 megawatt thermal. At that time, we have calculated the geothermal potential of Turkey, but we calculate according to our wells, our springs. But now the capacity is, the total capacity at the time Turkey geothermal potential is 60,000 megawatt, 60 gigawatt. But now we just use 60% of this energy. And then where we can use in Turkey, we can use for the resistant heating, 33%. We can use for the spa thermal hotels, about 33%. We can use for the thermal facility, like 12%. We can use for the greenhouse heating. I will show you some pictures, 23%. And then we have very limited heat pumps. You know that the heat pump is more in the earth because most of them used by the European, especially. And then also we can use for the food drying. Okay, this is the sample. This is picture show that about where the Turkish city have been heated by the geothermal. As you see in here, pink colors, we have some place is heated by geothermal. For example, in my city in Izmir, at that time we have about 38,400 houses have been heated by geothermal. Normally, we start in 1996 in here, in system. But in this system, in this region, we have also the cooling system. We have, the cool some place. And then this is the, Balchova region, Izmir site, my field in here, our living city. It's, as you see, that is controlled by tectonics. This is the fractures, if the fault, the major fault, and then this is the different geological unit in here. Okay, if you look at the geology, according to geology, we did many wells in here. We have 2 reservoirs. This is city in here. We have a shallow wells, and then we have a deep wells. At the temperature range from 50-60 degrees to 140 degrees. It is possible you can produce a power energy in here for power generation, but in this city we just use this fluid for the heating house. In this kind of the study, the important things, you have to really do very well geology, because if you have good conceptual model, if you analyze the fluid age, fluid system, fluid mechanism, this is the that this is the effect or all the technical point. Therefore, it is important you have really analyzed geological properties very well. You see that in here, this is the some fractures. Each one is a fault system, and the fluid heated by the geothermal is come to our wells. Okay, also for thermal tourism. And then, as you see in here, each part of Turkey, that this is the like a green colors. You see that all part of the system, they have a thermal tourism. Also, the government support thermal tourism. Therefore, we have some special region. For example, in here, we call that Central Anatolia Geothermal region. We call that Phrygian region. For example, this part, we call that the Southern Aegean Thermal region. You see that? Therefore, the people is used for thermal. And then greenhouse is very important in Turkey. And then we are in the greenhouse industry ranks, we are in the second in Europe. But for the geothermal, we are the first. Okay, these green colors is show that the greenhouse application. At that time, we have the biggest greenhouses in the world in Turkey. You see that it's one of the sample. Akrobay is not far from our city. But dear my colleagues, I want to mention that that especially we are produced the fruit, fresh fruit, but most of them is discard. Okay, most of going to the West. Or tomato, you produce tomatoes. If you are not just going to be discarded about 30%, 40%. Therefore, drying is very important. Dry food. For example, in Turkey now is the currently 4th place in the world in the fresh food and vegetable production. And then we have many dry industry in Turkey. Okay, this is some sample about the agriculture drying application in Turkey. For example, peach, date, watermelon, pear. And you see that we dry this one with the geothermal fluid. Okay, let's see about some hydrogeochemical, the environment problem related to the system. As you see that I take a cross section from western part of Turkey. Okay, this is the measured fault system in here. This is the detachment fault, and then some geology. I know that most of our colleagues in here, the electric engineer, therefore I'm not going to focus more about the geology, but if you have any question, I would be glad to answer. But as you see that this is cross section from the north to south and the northwest to southeast. And then as you see that all the system is controlled by tectonics, but some region they are affected by the intrusive, like maybe the volcanic. But in here we have some grabens in Turkey. But if you look at this is numbers, look at these numbers. Each number is one of the geothermal field. In here you see that we have some pie diagrams. For example, in here in the pie diagram we have a different color. For example, this is the green one is the sodium. The pink one is the chlor. The meaning that this is the fluid number 1 is sodium chlor. For example, in here, again, sodium chlor, number 2. But number 3, you see that in here, as you see that this is the sodium, and then you see that the sulfate, the yellow one is a sulfate, sodium sulfate. As you see that number 4, 5. But if you are coming in here, you see that some blue color. For example, this is number 15 in this side. As you see that this is the, for example, this is the sodium carbonate. And then if you're coming in here, number 30, 36, 35, 34. As you see that is it like a calcium, you know, red one. You see that calcium, the blue one, bicarbonate. The meaning that each geothermal field, they have different geochemical properties. This is affected the power generation production. This is affected the, you know, that the fluid mechanism. This is affected the, you know, that the, you know, that the, all the process. Therefore, we really should understand exactly the properties of the geothermal fluid in the system before the start to the use this fluid. For example, in here, I took 3 geothermal fields, 1, number 2, and number 3. It is not far from each other. This is the northwest of Turkey. For example, look at in here. This is the geology is quite different. You know, the control by tectonics, intrusive in here. But if you are going in here, you see that this part is again the intrusive, but altered other materials, rocks material, volcanic regions. But if you look at this side, is completely different volcanic reservoirs. But temperature is also different. For example, from here to here, temperature is going to be increased. Look at the just quickly chemical. For example, you know that the two sides is the sodium chloride, the other one sodium sulfide. But look at this one, electric conductivity. The electric conductivity of the Hıdırlar, you know that in the LED in center, you see the electric conductivity range from 948 to 1087 microsiemens per second. You can see that Istanbul is the 3000, the other one 70,000. Okay, as you see that each geothermal system, they have a different physical characteristic. This is affected the mechanism. And then if you look at for the temperature, you know, we used to fluid, we estimated the reservoir temperature because it's very critical for power generation. You see that in here, the temperature around the 80 degrees, but in here around the 200 degrees, but in this part is the around the 200, 250 degrees. Okay, if we used to some isotopes, isotope is the give the information about the source and age of the system. You see that this 3 system, the isotope is located in different region. For example, this is meteoric. This one is affected by the sea intrusion, but this one is a connate water. Okay, the meaning that each one is different. I took some pictures, some figures from the this is Larderura field in the Italy. As you see that if we have one of the aquifers, you know that the reservoirs, but in here this is unconfined because this is the, you know, recharged by the meteoric waters, but this is confined system. But in confined system, maybe, you know, that if you want to go into build the power generation, in greenhouse application, you have to be careful about this one. For example, in this is the fluid is sodium chloride, but in the calcium sulfide in here. The temperature 250 degrees, in here is 100 degrees. It's the same system, same aquifers, but the behavior is different because this part is we have an impermeable cap rocks. Okay, dear my friend, cooking pressure. You know that this is very good example about the power generation, the geothermal. Cooking pressure, you know, under the cooker pressure, we have a heat source. Cooker pressure is a reservoir, and then the cap of the cooker pressure, we have a cap, and then chimneys, this is fault. You know, this is sampleable. Okay, this again the other, the larger system, but sometimes, you know, the temperature 250 degrees, but if they, you know, that the open, no cap rocks, okay, as you see that we can see more cold sulfate meteoric system in area, and then temperature is very low when we compare the other part. Okay, in general terms, all chemical elements, both in gas and liquid, can be seen in the geothermal fluid. We have some trace and we have geo indicators. For trace like a chlorine, borium, bore, you know, that helium, argons, geo indicators, silicium, For example, for trace element, chlorine, we try to understand the source of the system. You know, for example, if you have helium isotopes, you can understand about distillate crust, other system. For example, if you have a sulfate and hydrochloric, it's maybe related magmatic chambers. But the other one, geoindicators, we can use for the geothermal. We use these elements for the geothermometers, geothermal functions, like a, you know, and then we have some gases. This is also very important for the system. Okay, you see that in here, as you see that many geothermal, each geothermal have a different properties, that they have different minerals. For example, in Turkey, in geothermal field, some geothermal field, because the calcium carbonate systems, they have this system, they have a carbon dioxide. You know that the quantities is high, the values, but we have a carbon dioxide in system. But normally, you know that we don't want to carbon dioxide in system. But in the world, you know, this picture from the Iceland, they used how to capture the carbon dioxide air, and then they used to and then they inject underground. And they have a carbon fix project in here. Okay, in this one, they first capture carbon dioxide directly from air using geothermal energy, and then okay, also the carbon dioxide mixed with water and pumped underground. And but when you are pumped the carbon dioxide, because carbon dioxide acids, and then they are going to react with the underground rock formation and is mineralized, binding the carbon dioxide permanently and safety is important. And this is the application of the site. You see that when you are going to inject the fluid underground, sometimes you can see some minerals, like a pirate underground system. Okay, this is the you know, that system in the Iceland, you know, that the collected carbon dioxide in the air. Because but if geothermal fluid, they have a carbon dioxide like a Turkey, it is possible you can capture this carbon dioxide and use for the system. For example, in some geothermal field in Western Turkey, they have a carbon dioxide, but the carbon dioxide capture, they use, you know, the production, they use for liquid carbon dioxide. You know that like a coke, many cokes, they have a gases, but this all gases come from geothermal. This is geothermal gases. Don't forget. This is very important. And then you know that fire is a very bad, but it is possible you can capture this carbon dioxide. You can store this carbon dioxide and then use this carbon dioxide for the fire regions. You know, still all the fire equipment, they consist of carbon dioxide. And then the other problems for engineering, for energy engineer and for mechanical engineer, you know that this is the production and this is reinjection in the system. For example, we have produced, use power generation, and after the reinjection. But after the flushing point, you know that, you know, the carbon dioxide degazing, and then temperature and pressure going to decrease, come to the surface. For example, temperature is 120 degrees in here, come to the surface, temperature 170 degrees. As you see that in here, 280 bars, you see that in surface, maybe 3 bars in reinjection. Okay, this has affected the chemical of the fluid. Therefore, in the system, we can see that scaling. You know that like a calcite scaling. This is, we can see scaling and corrosion is a big problem. For example, this is the production wells, this is reinjection well. In production wells, still they high temperature. Sometimes we can see calcite, siderite, dolomite, different scale. But if you are going to the injected fluid, you see that temperature is decreased, and then the more scale, like calcite, aragonite, dolomite. This is very important. This is the affected the efficiency of power generation. This is affected the efficiency of the direct use application. This is a big problem. Still, we have been working one of the big projects in Europe. This we call that the European project to 22. This is the project name is redefining geothermal fluid properties at extreme condition, because this affects power generation capacity. Okay, this is one of the power generation in the Turkey, in the western of Turkey. You see that this power generation. This is about 75 megawatt is binary power generation. They have just, you know that we have 2 wells, geothermal wells. We use this two wells fluid is enough for power generation. This one. But scaling is one of the important problems of the Tuzla geothermal field, this field, because reduce the efficiency of the power plant and cause economical losses scaling. In this site, in this field, you see that in pipeline scale, in the geothermal, into the geothermal system, especially you can see silicate-based scaling, which is the most difficult scale in the remove relatively observed. But we did very good study in here. In this power generation, we collected the carbon dioxide. We injected the carbon dioxide in the system, not underground. You know that in Iceland, they inject the carbon dioxide in the underground in reaction. But we inject in the system. But if you are injected the carbon dioxide in the system, you are the meaning that you are going to decrease the pH values. Low pH, no scale in this region. Because other case, you are used to some inhibitors, some chemicals. This is very expensive. But in here, this is very cheap system and the environmental system. This very good system. This system was done by our groups. And this is the used carbon dioxide for scaling. This is in this Tuzla region. This is our carbon dioxide tanks. You see it in here. We injected in the power generation for scale. As you know that most of the geothermal located on the tectonic boundaries, tectonic plate. Okay, this is measured tectonic plate. And then around to the tectonic plate, also we have many active faults. Like look at in here, this is like an Iceland region. And then we look at in Turkey in here. And then this is San Andres region. Okay. But in here, especially, look at this part. They also control many important fault system, tectonic system in here. But in this type of the fluids, sometimes they include many, high values minerals, such as the arsenic. For example, if you look at in here, the arsenic values is very high in Mexico, 162 milligrams. For example, in here, you know that some place like the Philippines, they have 34 milligrams. This is very high. Geothermal fluid is very important for the, for the thermal tourism, for the other power generation, but never drinking this water, because this water includes many minerals. Okay, this is the the distribution of the arsenic values in the Turkey. Some field they have high arsenic values, but also some field they have a bore values. This is boron. Okay, as you see that in here, normally that this is the for drinking water standard for the the boron. But if you look at the fluid of Turkey, we have a high boron. The high boron is, that if you are discharged to the fluid outside, that if you are discharged in the stream, if this fluid is going to be affected the underground system, the meaning that you are going to contaminate area. But you see that 96 milligram. But boron is very valuable. You know that boron is minerals. It is possible you can extract this boron. You can use this boron. I will show you some sample. And then also we can, one of the project, we used water, energy, food, nexuses, geothermal water for agriculture. We are treated the boron and arsenics. We used this fluid for agriculture. You see that this is our study area in the Izmir city. We have many sensors we control, but this fluid they have many minerals, but this fluid have no arsenic and boron. But we have not used so chemical, because this fluid have more minerals. This is the you affected and they make a positive, positive effect, improve the agriculture production. And then that in the mineral recovery from geothermal fluid it start in 1818. Larderora, they recover boric acid. You see that our Turks have a boron, that recover boric acid. But in some countries, they used to phosphate, for Mexico. Iceland, they used for they extracted the chloride, from the geothermal field. But now the metals, the geothermal fluid, they include some minerals like a lithium, mangan, zinc. This is very important. Especially, geothermal fluid contains significant concentration potential value minerals such as boron, strontium, lithium, gold, copper, zinc. As you know that we can use the different, the methods, different technique, different increasing challenging technique. For example, reverse osmosis. We can use evaporation, precipitation technique, oxidation, solvent, inorganic substrate with different techniques for the mineral recovery. And then that the demand of the lithium is expected to be increased drastically. This is show that the scenarios about how the lithium electrical vertical will going to increase. But in the at verticals, the meaning that you have need more lithium minerals. And then if you look at the price, that the price of lithium is going to be increased every day. This is very critical minerals now. Okay, and then it is possible you can, if you have a lithium in your system, it is possible you can use to recover this lithium from geothermal brine. For example, at the time we have small pilot system in the Turkey. We try to improve the system. We are used to the different lithium absorption materials. Okay. Okay, this is a study about lithium absorption efficiency using the CVA CDNT function with some hypersaline system of the Tuzla region. Okay, also it is possible you can use, for example, you have a copper. It is possible you can use geothermal. You can produce a copper sulfide. If you have a, that, for example, in some of the city in Turkey, we have a famous with the cheese, but waste of the cheese is salty. But if you are discharging this wastewater outside, this affect the surface groundwater, soil. But it is possible you treat this one. We used to the geothermal, we treated this one, and then we produced the whale material. This is that this is used by child, and then also salt production. The other important things, the energy geothermal system. I said that maybe you have, if you are going to deeper underground, you have not fluid, but you have energy. The energy geothermal system are geothermal reservoir enabled for economical utilization of low permeability, conductive rocks by creating fluid connected in initial low permeability rocks through the hydraulic, thermal, or chemical stimulation. But sometimes it is important, it is, that it is, if it is possible, you can make a jointed fracturing system, you injected fluid, and then after that you use this fluid for the power generation and then other direct use application. Okay, in these systems, that we have emerging future clean energy source in geothermal. This is for example, this is the fractured network system. In here, we are two wells, one of the reinjection wells and the other one production wells. You are injected maybe water, instead of water used to some gases such as the carbon dioxide, and then again you are produced heat, steam, vapor to generate fluid. And then also sometimes you can do one well, not two wells. You inject the water and carbon dioxide in the wells, and then around to the wells we call that the production wells, and then you can produce a hot steam vapor to generate electricity. And then some study was done in different parts of the countries in the earth. For example, in the Suez in France, Copper Basin in Australia, and then Aden in UK. They say that if, for example, if 1 cubic of the 1 kilometers cubics of granite they can generate about 79 plus 10 power 6 kilowatt hours electricity. If you used to, for example, we did some study with the Professor Chandra together about Turkey. If we say that we can use the this type of the energy, we can decrease the carbon intensive values in here. For example, in Turkey, you see that we have some granite in here. And then this is very important because this type of rocks, they include the uranium, thorium, potassium. This is the, that this produces energy. And then we published some papers about the geothermal reservoir system development and then carbon dioxide emissions mitigation through the enhanced geothermal system. How can, use this energy system? How can calculate the energy? And then how can we use this? And this is very good papers. It's quite new papers. I suggest that if you have time, please read these two papers. Also, I'm happy we did this study with our colleagues from the Indian, but he's still working. We are working in our university. Okay, as geothermal energy production is defined and expanded, the benefits continue to grow. With the continuous technology development, geothermal can be expanded all over the world, and already negligible environmental geothermal impact can be reduced nearly zero. And then geothermal system target the world. This production potential expected to be realized during the next 20 years period. It is important to understand hydrogeochemical behavior of heavy metal in geothermal fluids. Also, it is important to understand behavior of geothermal fluids in different pressure and temperature and different reservoir. Also, it is important to focus about geothermal mining, minimize toxic element in the geothermal system. But also, it is very important, increase geothermal power, procurement, and compensation. Also, it is important to increase funding for the technology and innovation. Also, it's important to streamline the permitting and leasing process. Also, it is important to increase financial support for geothermal power generation in all countries. If you want to minimize the carbon dioxide, if we want to minimize the fossil fuels, but also it is important increase heat pumps, subsidize and incentives. Okay, thank you very much. If you have any question, I would be glad to answer.
Thank you, sir, for your informative session. One question is regarding power production. We are talking about the three type of plants, especially the dry steam, flash steam, and binary cycle. What is the criteria in which we are going to fix which type of plant is to be installed?
Dear my colleagues, in Turkey, most of them binary, as I mentioned that. But if you have a high temperature, more high temperature, for example, 150 degrees, more than 150 degrees, they are preferred to the flushing system. But in the some flush system, they use for the water for coolings. They use the cooling system for water. But in Turkey, really we don't want to so much use the cooling water because we say that the water is very critical and we have to minimize the that the use the water for the cooling. Therefore, we prefer the air cooling system. For air cooling system, therefore we prefer the binary system. But I know that we have the other one, but I believe that in near futures maybe the double and then flushing to be maybe we can use for the different region. But okay, if you have a double flush, they also have a more efficiency, but they need the water cooling.
Okay, thank you, sir. Shine, please check some questions are in chat box.
Yes, one question. It's like this. How is the scaling affected on pipes due to geothermal fluid? Is there
Very
any
much.
cause?
Okay. Thank you very much, dear my friend. As you know that you can imagine cattle in house. When you are boil the water, you know that if water come from the carbonate, you know that you can see that scale in your kettle. For this one, you can use some chemical. Okay, but you can imagine power generation. The fluid comes from the pipeline, but in the pipeline, when they come to the surface, the temperature is going to be decreased. Pressure is going to be decreased. But when you are changing the pressure temperature, you can see them scale in the every part of the pipeline, vaporizer, that in each system. But for this one, for this system, we can see that is different type of scale, and then also corrosion. But for this one, we can use inhibitors. We use the inhibitor in pipeline. We use inhibitor in the valves, different valves. But at that time, the inhibitor is very expensive. Sometimes some systems, that they stop about for power generation, stop each mount. They clean the system. You can imagine. You can stop all the power. You stop it 3-4 days, clean the pipeline, and then is affect the efficiency, economy, efficiency. Therefore, for example, if you inject carbon dioxide, our system, it is working very well. We just stop each 6 months, clean 2 days. That's okay. Other case, because if the maze scaling, they reduce your diameter of the valves. This affects the production. Diameter of the pipeline affect your system. Vaporizer, that inside of the vaporizer, they affect each part of the power generation system.
Okay, thank you, sir. What is the largest capacity plant in Turkey by this tri-stream?
The largest one is the Zorlu Group at more than 250 megawatts electric. 250 megawatts.
How much deep is the well at that area?
Dear my colleague, this is the changeable to place according to reservoir. For example, in the deepest one in Turkey, 3,945 meters in the center of Turkey. The temperature is 341 degrees. But in the western Turkey, most of them is about 1,500, 2,000 meters. The temperature range from 100 degrees to 250 degrees. Yes, at the time we have a 3,000 meters wells. But for example, in Tuzla region in northwest Turkey, we have power generation. In here, the reservoir temperature is about 550 meters. All the wells is like 1,000 meters.
Thank you, sir.
You're welcome.
Any other questions?
Chandra, you have any comments for the India, because you're working so much about the geology of the India, tectonic, maybe our colleagues, because we are working with the Professor Chandra together, maybe you want to add something?
Yeah, it will be very much helpful because in India, geothermal energy is not so explored right now. Dr. Chandra can put some idea on the geothermal potential in India.
Chandra, mute.
Can you hear me?
Yes.
Yes, sir.
Yeah. India has a huge amount of enhanced geothermal systems, energy locked up in granites actually. In fact, we started a company called Geosyndicate, and we're trying to establish a power purchase agreement, the government actually, because geothermal is very new to India. Very few people understood what is geothermal, like, unless like Turkey. We did our best to make them understand what is geothermal. Still, it is not clearly understood actually. We have huge potential, especially in the Himalayas, in central India, the west coast, Narmada, Godavari. If you see some of my papers, I've given some potentials like how much you can produce. The main problem is power purchase. Who will buy the power act? Is the main issue being important. So we signed an agreement with Andhra Pradesh government at that time, then Andhra Pradesh government. They signed the PPA, but they did not fix the tariff. Even today, they did not fix the tariff actually. They always compare with coal. The coal is a different ball game actually. So coal, if you say we're able to sell coal to 3 rupees per unit, well then what are the consequences? You will spend a lot of money for cleaning the environment. CO2 emissions. Those issues are not there in geothermal. And then coal power is subsidized. You will be knowing actually. So these issues are not the geothermal, but they don't understand. And they want the geothermal power to be 2 rupees per unit. It is not possible. Economically, the capex will not allow you actually. So these are some of the issues. And of course, I think slowly it'll pick up and understand, and India will fall in line. A huge granites spread across the country. Actually, we are able to generate power from these granites. Actually, I did my best for 38 years, but now I am in Turkey. I'm very happy that Turkey is able to move forward with enhanced geothermal system. Very few years you will see one of the systems working efficiently, because the energy potential of Western Turkey is huge, actually huge, and they can reduce the gas imports, increase the renewable energy, especially geothermal energy in the primary energy source, and I can use it for desalination. Problem with water is solved. Problem with food is solved, and it is a good source for United Nations Sustainable Energy goals. Actually, you will see very soon. Alper is putting his heart and soul. He is one of the leaders in geothermal in Turkey, actually. And for any geothermal, people ask him, So I'm very fortunate to be with him. Actually, we are working together. Thank you so much.
Doctor, one more question regarding the cost of geothermal energy production. For 1 megawatt at present, what will be the cost production of a geothermal plant?
1 megawatt, rightly, for what we estimated in India, and there is a water flowing, it's about 11 to 12 crores, About 2 years back, it was the cost actually. And the power cost will be, you can sell it at the rate of 6 rupees per unit actually. You can get back your investment within 5 to 6 years. This is when the water is flowing to the surface. But when you're trying to extract the heat from granites, it is in the infant stages. We are not commercialized so far. So right now, the estimated cost is over 7 rupees per unit actually, but it will come down. The levelized cost of electricity will come down over a period of time.
Okay, thank you, sir.
Sir, one question. You have any studies in Kerala? Or
Kerala
any
actually
data?
don't have any. We have West Coast. We don't have any hydrothermal systems in Kerala. The system ends at Udupi, the northern part of where the Deccan Traps ends in the Goa granites actually. But then, having said that, we have huge amount of hot granites in Kerala. See, for example, in Achankovil, you have in South India, you have the Chanakites. These are all granites which are very high radiogenic, because you have the column, beaches are full of radioactive minerals. They are coming from the granites only. We have a huge source of heat available in the granites. And at some point of, because you have huge amount of water available, you don't care for other source of energy. At some point of time, we'll use this energy actually.
And how long it takes to construct one plant? I mean, what is the project time?
So about 18 months. 18 months. The time taken is only
establishing the
drilling.
plant?
Drilling is the time taken is only drilling. Once the drilling is in place, other systems you can buy off the shelf actually, install it. Now, as Professor Alper said, the binary system or ORC, you can just buy actually for different capacities and install it.
Fine.
And generate power.
all the project is take about 5 years. You know that do the geology, the valve.
Which one?
All the system. You know that if you want to produce build the power generation, 1-2 years takes for the geological research, valves, and then
About 18 months to the production side actually. Drilling takes
Yeah.
time. The bits and drilling. So, but now people are looking at oil wells, extracting energy from abandoned wells. That is the thinking now, especially United States is putting a lot of money to regenerate, use the abandoned wells actually. Because the bottom full temperature is about 260 degrees Celsius. So much of heat is available. And the drill holes are there, so cost is reduced actually. We can generate power from these wells actually. So we're also working on that actually. But in some time, Turkey will be the leader in the geothermal because considering the amount of resources available. The advantage is the Curie point depth, that is the temperature at which the magnetic mineral loses its magnetism, 580 degrees Celsius. It's very shallow, 6 to 12 degrees, 12 kilometers. And you won't get anywhere in the world actually, this kind of temperatures. A huge temperature.
Thank you, sir. Any other questions? Any other questions? So if there is no other queries, then we can wind up the session. I cordially invite our engineer Sabu Joseph for giving the vote of thanks. Sabu. In fact, actually, Sabu is the brain behind this session.
Oh, I see. Good. I was in Kerala for 7 years. I was the CWRD.
He went to Turkey recently, and there he saw the plans, and that was the initiative for this session. Okay, so I invite Sabu for giving the vote of thanks.
Sabu, you are on mute.
Sabu, please unmute. Sabu, please unmute.
Can you hear me?
Yeah.
Yeah. So it's very nice to hear that Chandrasekhar sir is worked in CWRDM, that is in Calicut, I hope. And anyway, nice to see you. And this is the day.
I didn't see you there. I was working.
Okay. This is the day KSCB Engineers Association got an enthusiastic technocrat and encyclopedia in geothermal energy, eminent scientific writer, researcher, geologist, Professor Dr. Alper Baba, Vice Rector, Izmir Institute of Technology, is a notable figure in this field. Knowledge has no boundaries, no caste, no creed. It flows from the high potential to lower. We really appreciate the sincere attitude of Professor Baba for accepting the request of KSCB Engineers Association to present the webinar. From the basic to the application to the future, it was mind-blowing section. The energy in your words will always stay with us and enlighten with new field of power source. The question and answer section was well answered. Thank you, sir, for the lovely section. We, KSCB Engineers Association, is delightful on your presence. And also thank you to your colleagues, Dr. Thaigan and Dr. Chandrasekharan, accompanying you and be with us on the pleasant evening. Let me take this opportunity to thank each one from different field of engineering who had participated to make this event successful. Let me also thank my colleagues and friends from KSCB Engineers Association who had been in this program and to those who attended live streaming. And I will not forget the webinar committee who worked in the background to make the event colorful. Thank you once again, Professor Dr. Alper Baba and his team. Thank you very much.
Very much.
Thank you, sir. Thank you, sir. So let us wind up the session. Okay. Thank you. Thank you very
Thank
much.
you.
Thank you. Thank you.
Thank you, sir.
Thank you.